Hi, and welcome everyone. This is the last week of the class in terms of instructor's lecture. And today I want to talk a little bit about CPS security, more advanced topic. And this is a photo of the Norfolk US Navy base. And we'll talk about the military CPS systems and the security issues. First off, there are assignments coming up, but please take breaks for your mental health, from all these work, and December is tough, even without COVID, and please, if you need more time, let us know. If you need help, do let us know. Defense in depth is something that the concept is very easy. You have your front door, your fences, you have your bedroom door, right? So it's something that you build certain type of redundancy in protection, and so in the physical world that's the case. In the cyber world, you want to have something similar. Multi-factor authentication is a fantastic example. If one fails, if you lost your phone, they don't know your password. If your password was hacked, they don't have your phone. GAO is the Government Accountability Office in US. A recent 2018 report find out huge deficiencies in the DoD, Department of Defense, military weapon systems, and that includes airplanes, fighter jets, Navy ships, tanks, and so on. Everything is connected. Everything is like a computer on wheels. And so what they found that delayed in patching, applying patches, not understanding the attack surface. And so in that case, you're confused about the threat model, confused about the deficiency, the vulnerabilities you may be exposed to. They did the GAO hire people to do some penetration tests, and of course some really horrifying findings. Guessed admin password in 9 seconds. And this I don't think they use manual guessing. They probably use some tools, but still 9 seconds is pretty short time. The last one is interesting. Operators thought crashing is normal, not due to attacks. And then this is, you think about, if you're the operator, this is indeed difficult, right? And this is a weapon system, you don't have a lot of experiences. If you run a computer, it shouldn't crash all the time. Back in 20 years ago, it does. It did crash all the time, blue screen showing up. But nowadays, you have a reasonable expectation what it should be. But then for weapon systems, you feel like, okay, maybe this is what weapon systems do. Officials expressed a confidence in the cybersecurity, but cannot provide any substantial evidence to back up their belief. And this is also very, very tough. You have taken this semester-long cybersecurity, there's not a lot of tools for providing this type of attack surface quantification, in a systematic view of your system, right? So this is still very much open-ended questions, but of course very dangerous if you're operating a weapon system. And so the good news is that this is a priority that the government is trying to invest. This is almost $250 billion invested on acquisition, research, procurement, and related to the weapon systems. And in the document, there's also a list of focus area, insider threats, endpoint management, encryption. So all the absolutely great directions. And so I did a little bit of exercise on to see, do the focus area match the GAO report, their full coverage. And so I find out there's good coverage in terms of username, password, encryption of files, these basic cybersecurity practices. But in terms of more complicated challenges, not understanding attack surface, not knowing the normal behavior of the system, right? Number 2 and number 8, there's no coverage. I cannot map this into that. And so this is what we want to talk about today, the defense in depth. And it is very much a new, still very open-ending research questions. And people are trying to think, okay, how should I begin to understand my attack surface? How should I know, what is necessary? How do I build this redundancy in defense and defense in depth? And so security, as you have known, it's really a risk management problem. And it's almost become a decision problem. I understand the risk, and I do some measurement, I deploy some defenses. I know I reduce my risk to a certain degree. It's never with 0, but then I'm okay with those pending risks. And so you want it to be a conscious decision. You don't want it to be a random decision. I just happen to have this Symantec solution. I install this, how good it is, how comprehensive, how complete, I don't know. So you don't want it to, you want to make an informed decision. And there's a lot of sort of folklore kind of thing about security, how to stay secure, right? So people always say, oh, maybe you just have a short mission time, right? You fly over to certain area to execute the mission, maybe 30 minutes, and you come back and you turn your machine off and you're done. How long can an attack take? 30 minutes, they probably couldn't attackers find time to hack you. And so indeed, some of the if you look at the statistics, some of the aircrafts, they have downtimes. Not all of them are up, right? And then when F-22 flying over the sky, how can you hack it? But then how long, you never know how long military equipment stay on and what turned on and live on for a long time. You never know. As a designer, as a cybersecurity researcher, designer, developer, you don't know how the people are using your solution. For one example is that the Patriot missile disaster back in the 1991 that hit, that failed to intercept the incoming Scud missile from Iraq, and caused that Scud missile hit the US military base and caused a substantial number of casualties. At that time, the Patriot anti-missile defense system had been running for 100 hours. And that's why the rounding system was way off, and it was calculated wrong. So you never know. As a researcher, you're like, you shouldn't turn this on for more than half a day, but then you never know. Short flight time, short mission time, no guarantee. Don't rely on that. Don't make those assumptions, because it's such a, from the design to procurement to deployment it's a long chain, and in the end no one talk to each other, right? The operator has no idea what are the assumptions, and so you do have to take that into your design. Secure by being obsolete, okay? That is also an interesting thought. And for example, COBOL was a 60-year-old language. When I was little, I find books about Fortran, right? Fortran, that was like 40-year-old language, and COBOL was even like 20 years older than that. Recently, because of COVID, it came back because some unemployment systems was written in that language. Military system, DoD has plenty, and we have talked about this before. In terms of the chip, the CPU generations, I would say 20-year-old, at least 20 years later than the consumer CPU adoption. Because they do have very strong and rigorous inspection systems. So you know, all the nice things, the great things, SGX, the trust zone, all these great things that we talked about cannot be deployed on those legacy systems, right? Unless you just completely rip off the old one and then put in the new chip, which again, there is a process for the government to adopt new technologies. But then, you know, there is a gap. How to secure legacy system. People want to work on cool new things, and they don't want to secure legacy systems. And so there is really a big gap. We do need to have young people, you know, researchers who are interested and who have some incentive to work on those topics. And for example, if you think about it, it can be very interesting too, how to have, you know, you have the old binary code, you know, source code is nowhere to be found, and how to maybe instrument it, that means change it statically or dynamically at runtime, so that you can have some checking. You can have some, you know, buffer overflow type of prevention at the runtime or statically without knowing the source code. And so it's very useful work. There's also a lot of some tools, but then there's, you know, the work needs to be done. So I want to say a little bit about ICS as well, industry control system. That's a specific type of CPS, cyber physical systems. DHS has a branch that DHS is responsible for securing ICS in the United States. This is a center called National Cybersecurity and Communications Integration Center, with a lot of big screens, and then they are in charge of disseminating the newest updates of attacks and vulnerabilities to power stations, utility companies, and then they welcome visitors, cyber camps, and this is a fantastic place to go. One of the particular branch called the CISA is running that operation room and together with other things, and it used to be called the National Protection and Programs Directorate, but after the 2015 OPM hack, it changed its name to CISA. OPM hack was pretty big. 21 million sensitive background check files, including fingerprints of secret agents, were stolen. And we briefly talked about this during class. I want to say a little bit more. And so this is a timeline that I put together based on all these reports online. And you see that it spends a year and a half, pretty substantial duration, and started back in 2013. And some of the defense contractors' credentials were breached from Key Point, and those are the companies who work for the government. And only the network blueprints were stolen. People are like, okay, fine. And then even until in the mid 2014, when New York Times reported this breach, and the OPM was like, okay, it was just a network blueprints and nothing serious. And you feel like, okay, this may be the end of the story. The reporter has already reported the OPM must have taken very serious job of securing their perimeter, finding out what's going on, and so on. No, that's is really the beginning, because in the next year is where the massive amount of data was exfiltrated and was breached. And so it was only confirmed in May 2015. And so in the May 2015, where OPM hired some companies, security firms, to dig into their logs. And then during that investigation, people find that there is this pinging connection from OPM machines back into a domain called opmsecurity.org. That domain was registered a month ago, and it never belongs to OPM. It sounds like it's related, but then no. And so researchers find out there's this malware called PlugX that was attached to some dynamic library. DLL is the library in Windows. And so they find out, they try to screen how many machines in OPM that have this malware. And they find out a huge number of computers got infected by all kinds of malwares, but only 10 of them have PlugX. And what PlugX does is, pinging back along with other things. And a lot of things are encrypted, so you don't know what's being exfiltrated. And then later on, they find out that it's that a data center gateway was infected with PlugX as well. And this is where they store the security clearance. And some of, every year I have students in a class that have already security clearance. And so this is where the storage of your long files is at. And so the government, and so after a little bit of looking at the logs, then they find out that there's this a list of suspicious credentials that may be compromised. But then they don't know, is it the actual user who accessed the data log, the data center, or the attackers using the stolen credential to access. And so they pinpoint to some contractors. Ask them to identify, is this your access? Do you recognize, do you remember that you use your credential access data center? And then one person realized that this one transaction, well, there's a few transactions that happened during July 4th of 2014. Okay, and then that person said, wait a minute, I was on vacation that week, the whole week, and so this cannot be me. And so that confirmed that particular transaction. And so, this type of, it's, they just confirm that the data get accessed. And so nice thing that they still have logs, everything logged, but then there's a huge amount of deficiencies in terms of not having firewalls, outbound proxies for preventing data loss, and for conducting what kind of traffic are going out to the outside. And there's no inspection of logs until people find out there might be breaches. And so they should really regularly conduct those kind of inspections. On the right-hand side of this figure that shows you the type of proxies that people are talking about. It's important to know that the man-in-the-middle attack are attacks in some people's eyes, are security defenses in others. And so a lot of organizations, and of course they don't tell you we're doing man-in the attack on all our employees. They don't tell you, but then they have proxies. The proxy act in a way that it essentially is doing man in the middle. And so that will enable the organization to inspect the plain text HTTP traffic. And so and then as long as you can justify this is not breaching employees' privacy, and the employee, if there's this type of proxy going on, you probably want to avoid certain very sensitive personal messages and then so on. But this is actually a very common practice. This is sort of an unspoken common practice for a lot of government agencies, and so we want to, in over the semester, we talked about all kinds of defenses, network system, encryption, data inspection. And so you should have in your mind the form of some idea of a defense in depth. If people ask you, how should I secure my perimeters? That money is not a problem. You should let them know that there are plenty of ways for you to defend and build this redundancy. And so, but then you do have to be consciously doing it. You have to know that it's important, it's necessary, and then you find out ways to build those defense. And so for me, it's always very disappointing and sad to see this kind of attacks happening, because this is all preventable to a large degree, all preventable. And And so, we talked about attack surface, the difficulty of assessing attack surface. It's really not the DoD's fault, because even for researchers, you ask the top researcher in the best, the most recognized researcher, what should I do to measure my attack surface? They won't be able to point you to certain tools. There's very few tools, right? So there are some tools, but then you don't know how good they are, and then how do they compare, and there's not a lot of study, systematic measurement. We do need to measure that to understand, to quantify it. But then, the biggest element, as I said, is raise our awareness and understanding. A lot of people don't understand. They were like, okay, I have Symantec, I have FireEye. But then you do need to understand it protects you for some aspect, but then others may be wide open. So for industry control system, it's difficult because it's a massive system. You have field devices, you have meters, you have computers, servers, you have like PLC, the programmable logic control, and you have like things that spins, and it's just complicated. And so you need to understand where they are, where are your assets, right? And then the security status of them. We shouldn't blindly accept security products, right? So because we all know security is relative, and it's all with respect to security, a specific threat model, and so and let alone some products, they're just bluffing. Okay, even if there's also commercial business aspect of it that ties into the cybersecurity, the science of it. So that just complicates a lot of things. And so we do need to have a third party, a neutral, objective third party who does the solid quantitative measurement. And so officials express confidence, and they do need to have supports. They do need to be told, you use our product, you use certain product, you achieve certain goals. And so right now it's very vague. And so we did a little bit of study, and of course I'm not saying this is the complete solution. This is far from being the complete solution. But I'm showing some examples to illustrate that what kind of measurement you could do. And we of course need to do millions of this type of studies, and also tie them together, build a whole defense in-depth, more holistic framework. So particularly we look at the address space layout randomization, the ASLR, which has fine-grained, coarse-grained. Coarse-grained is, Salman talked about this. Usually the starting location is different, but everything else is the same, right? So if you have application, sometimes you start here, sometimes start here, but everything else is sequential. But then you can also have a function, you randomize function location. The starting point of the function is randomized, and then everything else within the function is the same. And you can also go to basic block, and you can also go to each instruction level randomization, and also registers. So different level of randomization. JIT ROP stands for just-in-time return-oriented programming. Someone also talked about that. It basically says, okay, we can randomize the system by finding reusable gadgets to do return-oriented programming. Even though things are relocated, we discover where they are through call and jumps and function calls and all these logical sequence you needed for executing the program. And an attacker would leverage that to discover where instructions are and chain them together. So it's very disable ASLR. It rendered ASLR less useful, and so we want to know how useless is ASLR, or in other words, how many gadgets can attacker find? right? If you have those randomization. And so first off, we find that no existing tools can randomize libc library. Libc library has millions of lines of code. And it's certainly understandable in the sense that a lot of tools use libc library to power themselves, and so it's just you cannot lift your own body, and so that's just a glaring gaping hole in randomization. And so other than that, we find out the instruction level randomization is actually pretty good. But function and the block level are no good in the sense that the attacker will be able to still be able to find a huge amount of gadgets. So the percentage that's shown here is the reduction of gadgets, number of gadgets. So the more is good, more secure. And we want the, of course, nothing do 100% reduction. So there will always be gadgets left, but then are they sufficient enough for attackers to launch meaningful attacks? Well, we have some. So if you see the first row with the smiley face, that's the instruction level randomization. Everything else is not very good. And on the last column, TC stands for Turing complete, and that represents the attacker's ability to achieve things like addition, branch, arithmetic, type of operation, memory load. And so everything you need to achieve Turing complete, just once you have Turing complete, you can do anything. Instruction level does break Turing complete, but then you may not, attacker may use a partial Turing complete to achieve attacks. And so it doesn't mean that instruction level would always give you complete security, but that's certainly much better than the others. Re-randomization, we also measure how long does it take for attacker to get all these gadgets they need. And so this means that if you are if you re-randomize frequently enough, then you can, it's a race, right? So you want to do it spending too much time randomization all the time, like, because that's also causes overhead. But then attackers will be able to find the enough gadgets if the interval is too long. And so we find out 1.5 seconds to 3.5 seconds are good enough in terms of not giving them enough time to find Turing complete gadgets, and then you are not exhausting your resources just re-randomizing things. And so those are the very interesting findings. Another finding that we had is this is each row is a memory page. This is a selection of it that lists the discovered memory page through the JIT ROP attack. As I said, there's a lot of jumping around by attackers to discover the gadgets. And then it turns out wherever you start, you're gonna eventually find the same amount of memory pages for attackers. And so basically every road leads to Rome for attackers. And then this is interesting to know because sometimes you have leaked pointer, right? So the leaked pointer is an important starting point. It is a necessity in completing JIT ROP. And so regardless of where it is, the attacker will be able to discover all the memory pages of an application or a library. So this type of measurement and just understanding quantify security defenses are very important, and we need more of it. When our paper was submitted, it was eventually published in CPS, the top security conference. But then people are like, oh, this is not new. You should do new attack or new defense. But this is new. No one did that, and we need more of that kind of work. Securing OT as if securing IT. OT is operation technology, and IT is information technology. OT in the ICS setting, industry control system, that means the field device. And we need to. This is different. This is very different because OT requires considering physical environments, because in CPS it's very important. This physical part is not just a cyber, it's cyber physical system. And so you want to infer, is a command legitimate? Is a system action legitimate? Should I authorize this action or read, right? It really depends on the physical environment. Heating a room would not be authorized if the room is already very hot, right? Similarly, cooling down a furnace, would really depends on the temperature of the furnace. So that's the part that is really, it's so basic, but you really consciously understand that you cannot directly export a IT solution into an OT environment. And you have to do more. You have to secure IT. In addition, you secure OT. And how do anomaly detection work on legacy system, right? So we say that you want to store logs, you want to inspect logs, legacy systems, and so Honeywell virtualized a lot of the field devices. The field devices are deployed in the 80s, 90s. And they submit information into this sort of middleware layer that virtualize things, and so that you can connect to it, you can Wi-Fi connect to it, and then make it more functional, easier to monitor, and then you're achieving better security. Of course, you still have to secure the field devices in the sense that if the attacker bypass the middle layer, okay, and then directly attack the field devices, you still have to put up fences and so on. So and then of course there's a lot of economic decisions going into it. It's you do whatever. It's there's constraints of the cost. The cost is something that you cannot ignore. So this is a virtualization. So you see this modernized, but then it's all monitoring the PLC, old-fashioned PLCs. Patching, we talked about patching. There's a delay, and of course, this is 2017. Some statistics that shows the delay range from like a month to like more than half a year. Okay, so that's how long it patches, and understandably, people don't want to disturb an existing working system, so they're afraid of patching. Afraid of patching. Actually, my car got patched, and then my map was completely gone. And then they were like, okay, you just wait and the map will come back. and so it happens, for like new models, new systems. It is tough, but then it's not tough to secure Apache servers, and then still took half a year to patch it at Equifax, and this is completely unacceptable. Okay, and of course the company blame on this single lone system admin for not doing his or her job. But then and so by the way, so this is the Apache Struts. It's a server, and we talked about this a little bit. It has a vulnerability. The vulnerability is very similar to cross-site scripting, in the sense that it takes outside input from outside user into this function get locale, and then if there is incompatibility, there's an error, the system, the Apache server would try to display the input from the user. That's a big mistake. When you display external input that is not trusted, you're running the risk of executing attacker's command. And then that's indeed the case. Instead of showing it as a text, sometimes if you're not careful not sanitizing it, you end up executing that command. very similar cross-site scripting, and it's a sort of not very surprisingly, their website also has cross-site scripting vulnerabilities. Their freeze pin was set up as a timestamp. You know, pin is, that means, you know, it's easily guessable. People can unfreeze your pin, unfreeze your account. In the Equifax is you're gonna work with it because it's a credit company. Every time you apply for a mortgage, for a car loan, your creditor, if you borrow money, the borrower will check your account at Equifax, one of the biggest. There are 4, but Equifax will always, sometimes they check all of them, and also default username password in Argentina Equifax. Clearly, this answer is no. I hope that you all agree that they should have done much better. At least to have, you know, I would say the first thing they should do is that all companies should be aware of cybersecurity. And they should do this type of training again and again, education. And then they should hire capable people as directors. They should start to deploy, assess attack surface parameters, assets, start to deploy solutions and education training. And it's, for a big failure like that, you know that there must be no mentioning of cybersecurity at any level from day one, and so that's just completely unacceptable. If you know that they are sitting on a massive amount of sensitive information. So this is some rendering from a researcher on defense in depth, so the elements putting together, right? So, and that just to show you that the type of the visualization of defense in depth. As I said, evidence-based quantification of risk assessment, very necessary, because security is relative. You cannot say I use this. I have security. We also talked about the PCR, the payment card industry, the scanners. They have a huge amount of issues scanning and certifying websites, and end up certifying a lot of vulnerability websites. And so I see this as a very unique position, unique opportunity for researchers like me, doing this open, transparent, scientific studies. And of course, it's a very both useful and interesting. So I think that's it for today, and so this lecture doesn't need to submit summary. We'll see you later this week. Bye.